Hi guys, I'm Yuki from External Devil Japan at Solana Foundation. Today we will learn Solana's new proposal, Constellation, by actually clicking through it. After execution with Fire Dancer, consensus with Alpenglow, and wiring with 00. This is the fourth piece, a market structure proposal. It may sound like a dense academic paper, but don't worry about it. I built this site so you can just click around and feel how it works. Let's dive in. First, why do we need Constellation? In one line, the root cause of map, that is value extracted by manipulating transaction order, isn't bad people. It's a structure of monopoly. On Solana today, whoever holds the leader slot sees every transaction first and gets to pick and order them all. Let's feel that power. On Solana today, I pressed censor. Then a rival's order just vanished. No explanation needed, and my profit went up 0.4 Sol. That's censorship. Next, reorder. And my own order jumps to the front. Then the sandwich. I wrap my buy and sell around a whale's order. That's a sandwich attack. I made a tidy profit. And on Solana today, there is no protocol mechanism to stop any of this. Now let's try the same thing in a world with Constellation. I've switched modes. I press the same sensor button and a red invalid block. The transaction I tried to drop was attested by enough attesters. The notaries will meet shortly and it's fee competitive. So a block that excludes it gets rejected by the entire network. Not a fine. The block itself becomes invalid. That's the heart of Constellation. And the order and sandwich are both swatted away by a green shield. Order is fixed mechanically by feeds and contents are sealed by a hash. There's nothing left for the reader to do. One important honesty note, Constellation is not magic that erases map. What it structurally kills is hard censorship only. We'll be precise about this with the 3-layer board later. Then let's break down how it works. Then go to anatomy. From birth to landing in a block, a transaction passes through 6 stops. This time, instead of outplay, let's step through it one at a time. First, submit. The user sends directly to one or several proposals, that is the intake desks. And next, propose. About 16 desks are open at once, and every 50 milliseconds each bundles its intake into one P slice. Not one per slot, that's important. And next, encode. The P slice is split into 256 fragments. This is P shreds, and any of 64 of them can fully rebuild it. And next, attest. The attesters, this is notaries, sign that they received it. This collection of signatures becomes the record that binds the reader. And next, assemble. The reader's done, but now just a bookbinder. It must include attested P slices, and order is set by feeds, so discretion is near 0. And last, vote and replay. Validators check the finished block against the notary's record. Any mismatch and the reader's whole window is skipped. The journey is complete. Let's feel that any 64 rebuild it. Then I raise this slider, and this is a count. up to 63 it's foggy, and the moment we pass 64 it's reconstructed. So the reader can't lie that it never arrived. Denying existence becomes physically impossible. And finally, timing. The 50 millisecond cycle is the economic heartbeat. The slot is the unit of consensus. At the 400 millisecond slot, that's 8 bits. Now let's go to the theater. This page. 5 scenarios show how the ball reacts when attacks happen. And rows are desks and columns are notaries. A checkmark means received and signed. Then first, the normal case. Let's start. All signature gathers and every piecewise is included. This is our baseline. Next, targeted censorship. Let's play. P2 is well attested, but the reader tries to drop it. The result is whole block is invalid. The same thing we felt in section 0, now on the board. Next, mass dropout. Let's play. If notary participation falls below 60%, the block is skipped for safety. This isn't a failure under attack, it's failing safe by design. Then next, double sign. This is a desk cheating, making 2 different piece slices in the same cycle and handing them to different notaries. The contradiction itself is the evidence. No matter how many votes it has, just that piece slice is dropped unconditionally. The other desks are untouched. And finally, roll over. Let's play. Everyone is included, yet part of P4 moves to the next cycle. This isn't censorship. It simply exceeded the compute capacity and lost the fee race. The scenario shows the line didn't get in does not equal censored. Now let's go to the latency. And in this page, first comes in 2 kinds. First, on average, it's sequence latency, and a guarantee that in worst case you run within this window, it's inclusion latency. The bottom ruler is the former and the top ruler is the latter. In today's mode, I raise the reader's malice and send it like this, and it's held at the gate. The measure time below keeps stretching, and the top guarantee is infinity, and there is no guarantees at all. With Constellation, the load is a bit longer for the stops, intake, attest, and assemble. But even at max malice, like this, even at max malice, it always finishes before the golden guarantee wall. Let's do it. Like this. The worst case is bounded. That's the kind of fast that exchange-grade finance actually needs. So the famous debate between KB and Tori is actually a case where both are right. KB is reading the bottom clock and Tori is reading the top clock. They are simply reading different clocks. And honestly, this is a conceptual model, so no empirical benchmarks exist yet, so I'm not showing specific milliseconds. Next, let's go to the status. If it's a 2-story, the tickets, the inclusion fee goes to the desk that included you, and the reserved seat, the ordering fee, is the part you bid for order. The reader doesn't pocket it. It's returned to the system at epoch end. Why? Because paying the reader directly will revive ordering control via a paying yourself ticket. And how many disks do you send the same transaction to? One is cheap with minimal exposure, the default in calm times. And more means harder to censor and faster, more certain inclusion, but also more tickets and more parties seeing your contents. F4 may be overkill, which only a slim gain in certainty. The point is the optimum sits with the situation, and the core honesty point is the 3-layer board. Only layer 1, hard censorship, is structurally solved, and layer 2, content visible ordering, is partially addressed. And lastly, layer 3, millisecond timing games, is an open problem the white paper itself calls unpunishable, so we can say map disappears. Conveying this honesty is the most important thing in this video. And where we are now, the proposal stage with white paper version 0.9 published in March 2026. Alpenglow targets mainnet first, then Constellation. Every number can still change through the SIMD. Lastly, to wrap up, Constellation splits the monopoly of a single sun, the leader, into many stars, 16 proposers and 256 attesters. It contains censorship through structure rather than fines and gives markets a guarantee of inclusion. But it's not a cure-all. Some layers honestly remains unsolved. Wire Dancer, Alpenglow, 00, Constellation. The 4 pieces are finally complete. The site link is in the description. Please try it yourself. See you next time. Bye bye.